All right, we're continuing with calculus of vectors, right? Look at that. We actually finished up the derivatives. And we just have integration left to do. So evaluate the integral. And again, for this problem, I'll do all the intermediate steps, and then I won't ever do that again. So remember, how do we evaluate an integral? Since the integral is a limit, what do we do? For us to evaluate the integral of a vector, what do we do? Yeah, that's exactly what we do, right? We integrate each component individually, right? So this is this vector. I'm not sure if I mentioned it in this class or diffie-q, but I typically don't put parentheses on my integrals, even though that's mathematically incorrect. Yeah, because I'm lazy. It's tough to balance my math background and my physics background. Physics is always do everything practically, the easiest way. Math is more just prove it can be done. And that's what we're doing. How do you evaluate an integral? Just think back to Calc 1. What was the technique called? Or the result, I should say, the result called. And it was the most important result out of Calc 1. I'm sure we're going to be taking an antiderivative. And what do you do with the antiderivative?
You evaluate at the unknown.
How? So say that big F is your antiderivative.
It's going to be the top of the integral, because it's like.
What's that called?
Eval?
So what was that called?
Oh, computing the bounds.
That method that we just did. Find the antiderivative, big F, then it's big F of 2 minus big F of 1. What was that called? What was that result called? And you said you had me for Calc 1, so if you don't know this,
Yeah, I forgot.
you're in a lot of trouble. Because I emphasized it. You may want to clear your desk off so you have room to face palm or face plant. Fundamental theorem of calculus. It's just as works just as well. Actually, you need to do it a second time because you decided not to show up yesterday. Speaking of that, you two need to tell him how much he's missing. That he made a mistake in not signing up for our diffie-q class.
Oh man.
I'm going to be so real. I was like starving towards the end of that class, and my brain was like trying to do itself.
I'm going to be completely honest too. That's why I was in my classes. I actually had an instructor once tell me, you don't have to pay attention, just watch the Phillies game and go to sleep, I don't care. You clearly know what you're doing. I also had him for like almost every single undergrad courses. So I had him for almost like, because I also had him for a lot of undergrad, I had him like 4 or 5 straight years. So he knew, he was like, you don't have to pay attention. I was like, and so always the same way. He'll feel bad. What a terrible student.
Yeah, the difference is that I don't just notice stuff.
I also had my linear algebra professor. This is an 8 a.m. 3 day a week course. It was awful.
I hate it.
I'd rather have a
The rest of the class was struggling, so you have to keep going over topics. He actually just called me inside after class one day and said, I'll just email you when the exams you have to show up.
So funny. All the other kids in your class just were
Yeah.
able to.
I was the only one who actually understood it, so
Yeah.
it was bored out of my mind, and I had a lot, so he knew me. He was like, I'll just email you when the exams. You don't have to worry about showing up.
I feel like.
I think I got like 3 weeks off.
That's
Well, I'd rather have 8 a.m.s than night classes. Night classes sucks.
And 8 a.m. next semester.
I can force myself to be a morning person.
No, I can't.
After like a certain point in the day, I'm like, all right, this time is for me only.
No, I can't. There's not enough coffee in the world.
after like graduating high school, something in my body just changed.
Yeah.
I have not been able to like get up and be functional around that time. But like since then, it was just,
My cousin said that like I have the diet of a blue collar worker because breakfast most days was just the biggest protein bar I could find, and like a tall boy of Monster.
That's cute. Yeah, she eat breakfast.
Monster?
Yeah.
I skip breakfast.
I don't enjoy my.
Oh, I can't. Mine are like I get like nauseous if I don't eat breakfast.
What's the antiderivative of 3?
See,
Right, so I actually don't do that. I write it this way. You'll see why.
so but alright, this way you might answer this, but I'm gonna ask it anyway, and you can tell me like you're gonna go through it if this is the question. Why is you're saying t equal 1 and not t equal 1 and t equal 2?
Oh, that's again just out of laziness.
Oh, okay. Okay.
So the lower bound is understood that it applies to both lower and upper. Right, you're clearly not, if you evaluate, you're clearly not going to have
So
different upper and
So
lower.
then I guess my next question would be, there isn't another variable, so why?
Not yet.
That's why. Like later on, there'll be like T
When we do multiple integration.
Y, yeah.
Oh.
So I just got in the habit of writing what variable I'm evaluating. And also, you may have some integrals that have constants in it, but they're represented, like when you're doing motion, like we were doing yesterday,
Yeah.
you just use little g instead of 9.8.
Hmm.
So it's just specifying, well, here's what we're actually evaluating. And I kind of just got in the habit of it, so.
That makes sense.
What is the antiderivative of t cubed plus 14 to the 7th?
3 or no. T to the 4th over 4 plus 4t to the 8th over 8.
What's wrong with that answer?
It's 1 half t to the 8th.
And antiderivative for t.
T squared of it.
So there is our vector, right? Now it's just a matter of evaluating. Two minus one, 1 times 3 is 3. What's 2 to the 4th?
16,
Minus 1 to the 4th.
15.
So that first term is 15 quarters. What is 2 to the 8th? What was 2 to the 4th?
256.
Yeah. It looks like you're using a calculator.
I was.
That's a shame. You said it though.
I count my head.
Easiest way, well, there's actually two.
But what were you?
I kind of know up to 15 you can do 2 to the 10. Right? Or 2 to the 4th was 16. Well, 2 to the 8th would be 2 to the 4th squared, so it's 16 squared, 256. then 1 to the 8th. So it's 256 minus 1, which is 255. Not here. Oh, worry about simplifying that later, then also I think it's easy to do. 2 squared minus 1. Now it's just a matter of what is 15 fourths plus 255 halves. Well, 255 times 2.
That's
510, right? Add that, add 15 to that. It's 525 over 4. There's the integral. So, nothing new, again, okay. And this integral. Well, first, if we take the derivative with respect to time of v cross dv dt, right? Derivative of the first times the second, or in this case the cross, right? Plus first cross the derivative of the second. What's that first term? dv dt cross dv dt. What is it?
The second derivative.
What's any vector cross itself?
0.
0. All you're left with is that.
Why 0?
That's just a property of cross products. You can actually evaluate any vector cross itself and always get 0. You can also, if you have linear algebra, just use properties of determinants. If you take the determinant of a matrix that has 2 identical rows, it's 0. Well, by definition of antiderivative, that's just that. Notice the constant's a vector. When you go to do the homework and you have to do the antiderivative, you have to make your constant of integration a vector. Otherwise, it will not accept the answer. And this on this topic, that's the most common mistake on the homework. Is you just do a plus C, forgetting that it actually has to be a vector. Since I have a little bit of time, a little trivia. So we know that velocity, right, is the derivative with respect derivative of position. And derivative of velocity is what? Acceleration, right? So then the second derivative of velocity would be the derivative of acceleration, right? So rate of change of acceleration, what is that called? Rate of change of acceleration is the what? Again, you should know this.
The instantaneous.
Right, what's it called?
I don't know. Tangent?
It's the jerk.
What?
Yeah, sure.
What is that the formula?
That's the rate of change of acceleration. We never use it. Because in physics, we really only ever go up to acceleration, but they have a name for it.
When would you use that?
You know, that's why I said it's trivia. I've never used it. You never want the rate of change of acceleration when you're studying motion.
What would it be useful? Sure. No.
I guess would that be like an example of that would be like if a stick shift car is accelerating and like manually switch gears.
Maybe if you have to design.
No. Because does that really involve finding the rate of change of acceleration? How's acceleration changing? You don't really ever care about that.
Maybe if you're like designing for like, if you have like a linkage system or something like that, and you're designing for like minimal movement between something like that.
I've never used it.
Yeah, there's really, I don't think there's any.
Oh, by the way, jerk has a rate of change too. This is definitely really cool trivia.
I think that's a really good term.
Rate of change of the jerk is the snap. Oh, the rate of change of snap. There's a rate of change of snap. What do you think it's called?
Like,
You said torque? Torque is something else. Rate of change of snap, crackle.
what's that?
Rate of change of crackle is not.
No way.
Are you Atlas reading?
Yeah, that's right.
Oh my god. Wait. Snap, crackle, pop.
It goes position, velocity, acceleration, jerk, snap, crackle, pop.
They just gave up halfway through.
Wait, literally.
And then there's no naming, there's no nomenclature after that. There is nomenclature for before position though. Position is technically a rate of change. You just take its antiderivative. That has a name, but off the top of my head I don't know because it's not as cool as the snap, crackle, pop.
Oh, what is it a rate of change because it's like you're never technically stationary? Is it-
No, it's just a rate of change of something, right? Because every function has an antiderivative. Well, just about every function has an antiderivative.
Yeah.
Actually, that's also not true. A vast majority of functions don't. But in physics, when we study motion, a lot of them will have an antiderivative.
Such a freaky topic.
So that actually has a name. You can Google it. I'm not lying.
What is correct?
And I don't remember how far back it goes. I think it goes maybe 2 or 3 back. They have nomenclature.
And they just found that just to know that it's there. There's really,
Well, no, they just changed the name. Don't know why. They just did.
What's a jounce?
A what?
The same snap and jounce are higher derivatives. Like ounce with a J in front of jounce.
Where does jounce fall?
It's the same thing as snap apparently.
Oh, they may have come up with another name for it. Any questions on calculus of vacuums? Again, pretty straightforward. Right? Shouldn't be anything new. next 30 minutes, the worksheet, 10-minute break. So that'll take us to what? 2 o'clock. And then at 2 o'clock, we will start arc length and curvature, so geometry, essentially analytic geometry.
That was though, because he walked in and it was like mid cooking contest, and I was like, oh. He walked in and was like, dinner's red. Yeah. He's like, I'll give you a minute. And I was like, crazy. I was like, crazy, okay.
So funny.
Arc length shouldn't be anything new. Should have studied arc length at the end of Calc 2. Curvature. Oh boy. This is the definition of curvature. It's the length of the derivative of the unit tangent vector with respect to the arc length parameter.
So that's not magnitude?
That's magnitude. Magnitude of the derivative of the unit tangent vector with respect to the arc length parameter. That's the arc length parameter. Well, that's the arc length function. To find the arc length parameter, you solve the table. And then you replace that now new function of s into the original vector. Then from there you can find the unit tangent with respect to s, then the derivative of that with respect to s. And it's just a massive pain. So we know to use that. These are 3 formulas for it. For the most part, we'll be sticking with that middle formula. It's actually still a bit of a pain, but it's better. And then we have principal unit normal vector. The unit normal vector is just the unit tangent vector of the unit tangent vector. Unit normal is the unit tangent of the unit tangent.
Magnitude of the unit.
Remember what the unit tangent is?
Yep.
R prime over magnitude of R prime.
Yeah, okay.
Right, it's the unit vector that's tangent to the unit tangent. That's what the normal is. And that's guaranteed to be normal to the original curve. And then you have the binormal vector, which is just the unit tangent cross the unit normal. Right, and a lot of times, especially in physics, you look at the coordinate system formed by the tangent and normal vectors instead of the x and y. Curvature. Now we have R. We need R prime. So go ahead and give me R prime. What is it?
1, 2t, 2t squared.
And we're also going to need R double prime.
0, 2, 4t.
Now we need the cross product. Where t squared is the first component.
1 is 4t, and the 2.
Negative 14 and then 2, yes. I'll back up to 2. Makes finding the magnitude easier. Could have actually factored up 2 from the double prime, right? First, find the magnitude of r prime, because we're going to need that. Square root of 1 plus 4t squared plus 4t to the fourth, which can be simplified. One plus 4t squared plus 4t to the fourth is a perfect square binomial. It's 1 plus 2t squared squared. But 1 plus 2t squared is not always going to be positive. You take the square root, you're left with 1 plus 2t squared. There's the magnitude of r prime. Magnitude of r prime cross r double prime. Absolute value of 2 times now the magnitude of the vector. Oh wait, isn't that magnitude the exact same? This is always the worst part. Curvature is make sure I do it right now. Okay, good. Magnitude of cross product over magnitude of the derivative cubed. There it is. 2 over the quantity 1 plus 2t squared, all squared.
So these cubes, you just use that's the formula for curvature?
That is the formula for curvature. Okay. And again, to see where that cube comes from, just watch the lecture videos that you derive it. So curvature is a measure of curviness. The larger the curvature, the more curve there is. We're going to skip the plotting part of this. What kind of shape is that? That's a helix.
Three-dimensional.
Hmm?
I said a three-dimensional.
Well, helix is three-dimensional, right?
Yeah.
Call it
I didn't know what the actual shape was.
I guess call it a
I
spring.
just said a three-dimensional.
We want to find unit tangent, unit normal, and binormal. I'm going to write up to. I'm going to write off time for some reason. Remember to find the unit tangent. R prime over the magnitude of R prime. So we need R prime first. What's R prime?
3, -3 sine t, 3 cosine t, 4.
What is its magnitude?
Square t is 9 cosine square t plus 16.
Fully simplified.
5.
It's 5.
Wait, how?
You take out the constant and then the sine square t and cosine square t is the identity equals 1.
God.
Yeah.
That is the unit tangent.
Are we done?
For the unit tangent.
Which is the first one, right?
No, the second one.
So what is the first one?
It's just r for and then the magnitude.
Oh, okay.
Unit normal, we're going to need the derivative of t. Probably easier to use that first one. What's the derivative of the vector?
Cosine of two.
I ignored the fraction. I'm looking at the first component. Sorry, down to 1/5.
Oh, okay.
So just the vector that comes after the 1/5.
cosine t. Negative 3 sine t. 0.
I agree with 2 out of 3.
Is it a unit error? Did I write negative wrong?
Yeah, it is a sign error.
Okay.
What happened to the negative in the first term?
-2.
Oh, shoot. Never mind. I got my derivatives mixed up.
You need its magnitude. Absolute value of a fifth times the magnitude of the vector. What's the magnitude?
It's
So what's the magnitude of the vector?
negative 3 cosine of t all squared plus negative 3 sine of t all squared all of it square root.
It's just 3. When fully simplified.
Oh, yeah.
Oh, yeah, because the cosine and sine are just. Is that dot or?
That's the multiplication of scalars. Normal vector. One over the magnitude of t times t prime. Or I'm sorry, 1 over the magnitude of t prime times t prime. Negative cosine t, negative sine t is 0, right? Now for the binormal. Binormal is the unit tangent cross the unit normal. Again, I'm leaving that 1/5 factored out. Because we can use the scalar multiple property to say it's going to be 1/5 times now the cross product of just the vectors. Zero minus negative 4 sine t, right? Second component would be negative 4 cosine of t minus 0.
Yeah.
And the third component, 3 sine squared minus negative 3 cosine squared, which is what? Just 3. And here's the binomial.
Why was it for when we get distributed?
Because I forgot. So that would actually allow us to create a new coordinate system, the TNB coordinate system. Right, the binomial vector, so you could think of the T vector as kind of like your x-axis. The N vector is your y, and then the B vector would be the Z.
What would that represent?
Well, it's used, what we use a lot in physics, the TN coordinate system. And so a lot of the times when we're dealing with force diagrams, we don't really use X and Y. We usually care about the direction of force parallel to motion, that'd be your T. And then you want the normal, force that's normal, that'd be your N. So you decompose your vectors into the T and the N. So that's typically the coordinate system we work with. And then if you just want to represent as three-dimensional, now you have your B. Because how is the Z found? It's essentially the axis that's perpendicular to both X and Y. Well, what vector is perpendicular to both T and N? The cross product, which is B. So that would be the TNB coordinate system. Right, and that's useful, especially when you're starting to deal with slopes. Right, because then you don't care about the force that's horizontal, right? You care about parallel to the actual slope itself. That's your T. Good. Length of this curve. Arc length, there are two ways to represent it. Typically, it's little s that's used. I also sometimes would use L to represent length. But either one. I'm just trying to stay with the little s. Oh, by the way, this is a named mathematical symbol. ELL. So if you're using LaTeX or something, with the script L, that's LaTeX code ELL/ELL. That's its name. It's the integral from 2 to 3, right? You integrate over the interval. Magnitude of r prime. What is r prime?
5, 4, 1.
Oh, that's a nice one, isn't it? What's that magnitude?
42.
What is it?
42.
Make sure you do that integral real quick. Just root 42.
Wait, what?
If you just integrate over an interval ds, it's the length of the interval.
Okay.
Right, so what's the length of the interval 2 to 3? So it's root 42 times 1, which is root 42. That is a problem that we will be using a lot in this course. There's 3 useful properties in general. That one, and then there's going to be one for double intervals and one for triple intervals. When we get to it.
So
That just makes the evaluation easier.
So it would just because it's a constant?
Yeah.
It's 42.
Root 42, because it's constant. So it's root 42 times the length of the interval. Right? Because what we're doing is we're essentially just factoring out that 42. Right? Then you're just left with integral dt, which is the length of that interval.
And that's the, I guess we should have to do this too. Oh, it's just one. Never mind.
Yeah,
that's why.
Never mind. As soon as I asked it, I was like, wait a minute, that's just one.
Fix that. And so consider that curve. We want to compute the length function. Notice that it's not giving us a starting point. We're going to assume t equals 0 as a starting point. Then this is our length function. Integral 0 to t, magnitude of r prime of u du. What's r prime of t?
E to the negative 5t. Negative sine 2t. Cosine 2t. And so.
So chain rule is definitely forgotten.
probably.
And product rule is forgotten. Which product rule?
The 5
Right, which product rule? There's 3 of them.
product vector.
Because you have 3 types of products when you're dealing with vectors, right? Which type of product is this? First off, list down the 3 types of products. When you're dealing with vectors, what are the 3 products? Cross, dot, and what else?
up. Cross up.
Scalar multiple.
Oh, scalar.
Right, product with a scalar. Which one? So of those three, which one is this? Scalar multiple. So you're using the scalar product. They're essentially all the same.
Would you use chain for stuff?
Well, chain rules used when you actually go to take the derivative. Right, so you don't use chain rules here actually taking the derivative. So the chain rule would apply when you take the derivative of these two first, with what was written down. Then the second component, the chain rule would apply when you take that derivative.
So wouldn't it be the chain of the cosine sine first and we were taking the
So you have to apply product rule first. Chain rule, generally speaking, is always done last. Or you could just do that e to the negative 5t in, right? And then take the derivative. Then you're going to have three product rules. One, well, actually two product rules. First two components. Doesn't matter how you do it. Let's do it that way. That would be the first term, right? Plus, now what's the second term? Now simplify it. Factor out that e to the negative 5t, right? Then what are we left with?
Minus 5 cosine t.
That'd be the first component, right? Second. Oh, and then third. By the way, at this point, I don't like all those negatives. Although I don't think it's really going to matter, because we have to find this magnitude anyway. If we were to find the magnitude, I'd probably factor out a negative as well. I don't know if I want to. Maybe. I will.
Square, that doesn't matter.
That's why I said because we're finding magnitude, it's not going to matter. There's our prime. Yeah, that's the fun part. Gotta take that magnitude. Oh. Absolute value negative 5. No, not negative 5, sorry, negative e to the negative 5t times the square root. Square of the first component plus square of the second plus square of the third. Well, at least that third component's going to be nice. What is the absolute value of negative e to the negative 5t? I just think it's annoying. That is locked. There's the lock on this one. Oh, nice. Sure. Absolute value of negative e to the minus 5t. Absolute value strips across products, right? What's the absolute value of negative 1? What's the absolute value of e to the negative 5t?
E to the 5t.
E to the negative 5t.
Why?
Because
Huh?
It's only work on.
a negative power doesn't necessarily mean a negative value.
Isn't e to the negative 5t positive for all values of t?
Because it's 1 over e to the 5t.
So that's always positive, so you can just drop the absolute value. If that was absolute value of negative 5t, that would be 5 absolute value of t. Because t could be positive or negative, right? You don't know. But because it's e to a power, you know it's always positive. So you can just drop the absolute value. Now comes the fun part, algebra. Expand out that first term, what do you get?
Close on. Square 2t.
Second term,
Square 2t.
cosine here. That is hideous. So I'm going to do this to represent the square root of that whole thing. So this is also common notation, especially in situations like this. That's 0. That's 4.
54. Square.
That's 25. That's just the square root of 54. So yes, it looks hideous, right?
That's crazy.
Actually, let me change this highlight color. And can that be simplified? What's the prime factorization of 54?
3
And it's 2 times 3 cubed is the prime factorization of 54. You have a perfect square in there.
3, 6, 5.
Thankfully, that square root simplified very nicely. Imagine if it didn't. You can start to see how maybe the arc lengths are kind of hideous. I'm going to write it this way. Can back out the 3 root 6. What is the antiderivative of e to the negative 5u? And that'll get evaluated from u equals 0 to t. What I'm going to do is get rid of that negative and flip the balance. What is e to the 0? Then we're going to have that. That is our arc length function. I'm going to rewrite it. Now, it didn't ask for it, but let's find the arc length parameter. Well, I'm sorry. We just found the arc length parameter, it's S. Let's actually solve for t, because that's what you have to do if you want to find the R of S. That'd be your first step, right? Multiply both sides by 5 over 3 root 6. Subtract 1. Multiply by a negative 1. Let's take the natural log of both sides now, right? That's your t. which means R of S, you take that entire thing, what we just said T equals, plug it into the table. That's your R of S. And this one was a rather tame arc length, parameter 1. So what was the definition of curvature again?
Curve is
No, that's its representation. That's what it represents. That was your first step, if you're using the definition of curvature,
oh my god. That was only true.
is to find that what T is in terms of S.
Oh my god, stuff.
Second step is now replace T and R of T with that function. That's now your R of S. Third step is take its derivative with respect to S. Fourth step is to find that magnitude. Fifth step is then 1 over that magnitude times R of S. That's your T of S. Sixth step, take that derivative with respect to S. Seventh step, find the magnitude of the resulting vector. That's your curvature. Again, you appreciate those formulas a lot more now. And again, that's tame. Any questions on this?
Why is it so long?
Because arc length parameters suck. Okay, so I have two options at this point. Actually, I only have one option. Never mind, I didn't bring out the worksheet. I was going to say I could give you the worksheet now and just do the entire 125 minutes of the next class as the review worksheet. But I don't have the worksheet with me, so.
Oh, is the next class the review for the test?
Is this test for what, Wednesday? Or
We don't meet next Wednesday.
Oh, Monday, right?
It'll be following Monday.
So we don't meet on Thursday either?
Nope.
Okay.
Next week's a 5-day weekend.
Yeah.
So what we're going to do, because I still have like half an hour.
We could just leave.
That is
We
true.
did, watch an episode of Art.
No.
Bro, we could just jump right to the guard and Rock Lee fight, get peak.
No, word.
Watch the best episode right there. Don't even worry about anything else.
I don't know if that's the best fight.
Sure.
It's one of them.
Gar versus Rock Lee. I don't think so.
It's up there.
It's up there, but I don't think it's the best fight in the series.
I like
What do you
the.
think?
I just liked it before it got all crazy with the crazy jutsu.
I think the best fight
Kakashi
was
versus Zabuza
yeah.
was good.
no. Versus who?
So I'm going to show.
I was gonna say-
Giant sword.
I was gonna say my favorite fight in the entire series is Kakashi versus Obito.
Oh, yeah.
Yes, bro.
Kakashi versus Zabuza.
Yes, bro. That fight was good.
First, I'll bring this up.
Okay.
So I went yesterday, I actually realized I never actually put the extra credit file in the assignment.
Yeah, I think we read it.
So it's there now. So the actual document is now there. Oops.
Due before on the day of the first exam?
Due, it should be due before
The first exam. Okay.
the first
So
exam.
1 o'clock.
So beautiful.
Yeah, so I don't know how you're going to do it. You have to bring it in when the next section starts. You're taking the exam here.
Is it an online solution?
Testing server.
Oh.
It's going to be in. Oh, wait. Yeah, it is. I'm sorry.
Oh, it's online?
Yeah,
That's right, it's gonna be an online submission.
I was gonna say.
For some reason, I think you're turning it into class.
I was gonna say. I mean, I'm submitting the homework for different?
I'm thinking of, the homework that's gonna be a little bit tougher.
No, because
Just bring it up.
you can still teach it.
Yeah, but I'm breaking it during the exam. Say
Or
something for the next assignment, so that I know how it's gonna work.
Monday.
Cause the credit,
Unless you don't mind waiting
the
to
group
start the
assignment,
next
and then,
homework journal assignment.
yeah, the.
Because I can stay home and do it, right back.
Yeah, cause like the hardest part, I think,
So,
was struggling
that's
with
where some-
formatting and laptop and all that.
Alright, so the extra test now up there, don't forget to fill out that green sheet.
Yeah.
I'm gonna stop the recording for copyright reasons.